again, this is an example for a non-parallel tangent for a reverse curve. Basahin muna natin. A reverse curve connects three tangent lines with azimuths as follows. AB of 252 degrees 16 minutes. BC of 314 degrees 10 minutes. And CD of 216 degrees 48 minutes. Now, the degree of the first curve is 6 degree. And the stationing of the PC is 2 of 410.80. What is now the stationing of PT if the line BC is 164.71 meters long? Alamin natin kung ano yung line BC muna for us to solve for the station of PT. Ito ang goal natin for this particular problem. We know on the problem the station of PC, which is equal to 2 of 410.80. So once we will now draw the figure for this problem, now AB or tangent line AB has an azimuth of 252. If you could still remember your angular prelims in the discussion for the measurements of angles and directions. Azimuth from south reference, that is point A of 252 degrees 16 minutes, then point B. And B to C is 314 degrees 10 minutes. So that is our 314 degrees 10 minutes. B, C. And C to D is a 216 degrees 48 minutes. Ayusin nyo na lang sa drawing ninyo, no? C to D is 216 degrees 48 minutes. Plot natin yung ating curve, no? First, we need now to identify the radius or the radius of our reverse curve in our drawing. Likely, ito yung ating radius. Then, ito na ngayon yung ating curves. Okay? So, in a reverse curve, of course, we have our point of curvature, our point of reverse curve, PRC, and our point of tangency. Then, the radius of the first curve, and the radius of the second curve. Given in the problem that this reverse curve has not does not have an equal radius. So magkaiba yung ating simple curve connected by a point of a reverse curve. Then the station of PC is 2 of 410.80. Central angle of the first curve and another central angle of the second. Kunin natin ngayon yung angle of intersection for the first curve and the angle of intersection for the second curve. Now, notice that the line or the length of line BC is 164.71 meters. In our figure, B to C is the line for tangent 1 and tangent 2, which is basically your common tangent in our reverse curve. So BC is the length of our common tangent, 164.71 meters. Dali na yan. Pwede na nating isolve yung radius 1, radius 2, angle of intersection for the first curve and the second curve, then the arc length and the arc length of the first and second curve. For us to solve this station, which is the station of the point of tangency, kailangan natin si station PC plus the length of the first curve or the length of the first arch plus the length of the second arch. And for us to solve for the length of the first arch, again, that is angle of intersection of the first curve times the radius of the first curve times pi over 180 degrees. Same goes with LC2, I2, or 2 pi over 180. Nababasa po ba? Okay. So from that, let us first analyze the figure for us to solve for the angle of intersection of the first curve and the second curve. Angle of intersection for the first curve, notice that line AB has an azimuth of 252. So line AB, ito yung line AB natin. That is 252 degrees, 16 minutes. While line BC is 314, 10 degrees. So, anong gagawin natin dyan for us to solve I1? Madali nyo naman na makuha yan, di ba? Alam nyo naman na yan. I1 is now 314 degrees, 10 minutes, minus 252.96. Ay, 252 degrees and 96 family and Benekbine. That is supposed to be 15 minutes. So I1 314 minus 252 in minutes. That is 61 degrees 54 minutes. Okay? Ganun din sa I2. Paano natin kukunin yung I2? Baliktarin lang naman natin yan. Ito ay 314. 314 and 10 minutes. Basically, I2 is 314, 10 minutes minus 216 degrees, 48 minutes. Which gives us angle of intersection for the second curve of 97 degrees, 22 minutes. So just like what we did from last meeting for the compound curve in solving T1 and T2, given yung ating common tangent, meron naman na tayong I1 and I2, pero wala tayong radius 1 and radius 2. But in a given problem, given yung ating degree of the first curve. The degree of the first curve is 6 degree. Remember our computation for the degree of curves. Using degree of curve, that is 1145. 0.916 using metric system. R1 is 1145.916 over 6 degrees. So the radius of the first curve is now 190.986 meters. Substitute natin to the formula in solving tangent distance, T1. Ito yung ating right triangle. Right triangle po ulit yan. Again, that is now tangent I1 over 2 equal to T1 over R1. Diba? Kaya nyo yan. T1 is equal now to the radius of the first curve tangent the angle of intersection of the first curve over 2. Solving for the tangent distance of the first curve, R1 is 190.986. Tangent I1 of 61 degrees 54 minutes over 2 gives us T1 equal now to 114.529. Nagets po kung saan nakuha yung T1? Hello? Now, meron na tayong T1. Meron tayong common tangent. So basically, we can then solve for the T2. So T2, simply 164.71 minus T1, which is 114.529. Okay? T2 is now equal to 50.181 meters. And both tangent distances are now computed, but not yet the radius of the second curve. Yan na lang ang kulang natin dito sa LC1 at LC2. So radius of the second curve is simply T2 over tangent angle of intersection of the second curve over 2. Ito ulit yon, yung ating right triangle. Okay? No? Gets po kung saang right triangle na naman natin kinuha yan? Ito po yan. Okay? Okay? So substitute na lang natin ulit. R2 is now equal to 50.181 over tangent I2 97.22 over 2. So radius of the second curve is now 44.111 meters. Meron na tayong radius 1. Meron na rin tayong radius 2. So, and meron na rin tayong angle of intersection for the first curve and angle of intersection for the second curve. We can now solve for the length of the arch for the first curve and the second curve. Okay? Dito ko na lang ilagay. Colon solution. Baba. Kuha nyo naman yung figure I-move ko lang para makapag-ano ko. Now, the length of the first arch is simply the angle of intersection of the first curve times radius of the first curve over 180 degrees. Angle of intersection 61 degrees 54 minutes Radius 1 is 190.986 times pi over 180. Length of the first arch, 206.333 meters. Same goes for the length of the second arch. Angle of intersection of the second curve times its radius times pi over 180 degrees. Again, 97 degrees 22 minutes times radius 44.111 pi over 180. That is 74.961 meters. So we can now immediately solve for the station of point of tangency. Kompleto na yung ating requirement sa equation na yan. Station PC, meron na rin tayong length of the first arch and length of the second arch. Okay? Now, station PT or point of tangency is simply equal to station PC plus the length of the first arch plus the length of the second arch. Station PT now equal, ano yung station PC natin? That is 2 of 410.80. Plus length of the first arch is 206.333 plus 74.961. Okay? Stationing of the point of tangency is now equal to 2 of 692.094. Ito na ngayon yung ating final answer. Okay? Nagets po yan? Naintindihan po yung drawing? Hello? Naintindihan na. Hopefully naintindihan nyo. So later on, kung actual surveying na yan and plotting or laying out of data, ganito lang naman yan. Ito yung ating center of the identified road or lane. And offset lang tayo sa center niya to create or first and second lane of the road. Okay? And ito na mismo yung ating roadway. Yan na yung mismong curve. Then, you will have to categorize that by identifying each full station within the curve length or the arch length. Every full station po, kailangan nating i-plot doon sa ating layout later on. Kasi sa every station na yon, pwede nating lagyan ng culvert, pwede nating lagyan ng clearing, pwede nating lagyan ng signages, and pwede din nating lagyan ng iba pang requirement or road safety requirements. Okay? Yan lang naman po yan. Question. Question po. Okay.